Josh, to explore the universe, NASA is testing new technologies in space. See how the ocean provides an immersive environment to push the limits of space exploration. Our own NASA looks at places that replicate right here on Earth. Other places in the universe where we can explore. NASA calls these analog tests because these places are similar to places like the Moon, other planets, and asteroids. You know, when two things are similar, they have a similar relationship. You probably finished the word analogies in school. Things like Jupiter are to Titan as Earth is to, yes, Luna. Our Moon. NASA explores the same kind of thing. Similar relationships are being studied by NASA rovers in Hawaii, where volcanic soil is like the soil on the Moon. Be like what you'd find on another planet or perhaps a larger asteroid, and NASA studies the effects of gravity in Key Largo, Florida, beneath the surface of the Gulf of Mexico. We got some help from NASA engineer and special real-world correspondent Heather Paul, who had a fisheye view of the events in Key Largo. Heather Paul, thanks Josh. We're here in Florida, the Keys, and it's a truly unexpected place. You don't think about it when you think about going to the Moon or Mars, but actually, NASA is doing underwater research. This is the facility where the Aquarius habitat is, which is just the world. The underwater research habitat is about 5 miles off the coast, and it's the closest thing to living in space that we can find anywhere. Josh, Bill Todd is the mission manager for NASA's underwater research activities. Bill, and what we do is we send crews, astronauts, research crews to the habitat, and they go and live there, to get a sense of what it's like to be in space. Josh, the underwater environment mimics space exploration in several important ways. First, it provides an isolated, fully engaged setting, like what astronauts might encounter exploring other planets, moons, etc. In this environment they can test different systems, such as communications and life support, in a realistic setting. And that has a huge advantage. More than simulators solve this problem. Think of the fulcrum as the center of the equation. What is the equation on one side? The equation must be balanced with the other side. Remember that our board is 5 meters long. 5 meters is equal to 500 centimeters. The fulcrum is located on the center of the board, 250 centimeters from the end. If the child weighs 20 kilograms and sits on a mark at the end of the board, he is 250 centimeters from the center. Where will the other child be? The balance of the saw needs to be seen. We can write the equation for the saw as follows: base times 250 equals 25. By balancing the equation, we can determine the distance from the fulcrum that the other child should sit. The board will balance when the child weighs 25 kilograms and sits 200 centimeters from the fulcrum. This is 50 centimeters from the end of the board. The team in Key Largo often uses this kind of mathematical reasoning to solve problems, like finding the center of gravity for many different types of research activities. Here is another example with Nick and Heather. Nick, actually you have a same bag. Why don't you have your bag? Now imagine that you were outside, working, and you had a shovel. And actually, pretend you were just in your backyard and you were just shoveling some stuff. Heather, can I go to the moon? Nick, okay, not yet. Heather, oh. Okay. Okay. Nick, not yet. Okay, so you go there, you are the shovel. Okay, it's very easy, okay. Heather, yeah. It's easy. Nick, now imagine that someone comes along and they put a jug of water in your bag. Heather, okay. Now it's getting kind of heavy, Nick. Nick, okay. It's getting kind of heavy, so try again now. Heather, yeah. I think I will. Maybe I'll have to change how I'll shovel. Nick, okay. And so it's changing our center of gravity, so we have this CG rig that allows us to change the center of gravity from being very far back to being very far forward, very high to very low, and even towards if we want. And we can see how that affects the crew's performance when doing a large number of activities. Josh, once they figure out how to the rig optimally, they can take this lesson learned and applied to the actual portable life support systems that astronauts will use on EVAs. NASA has more analog tests planned throughout the year. Key includes more work on Largo. You can follow the progress on www.nasa.gov. Credit goes to NASA for this information.